Hello everybody, my name is George Mingo and I'm part of Challenge 2016. Now, today I'm going to be teaching you how to go through the steps of some problems of integrals using U-substitution. So the first thing we're going to look at is to find the definite integral with bounds -2 to 2 of 2x over 1 plus x squared dx. Now, when you look at this, you have to think about which of these you can use for your u. So in this case, you have to use u equals 1 plus x squared because that will solve the problem the easiest. And your du, which is just the derivative of our u, is 2 of x dx. And now we can plug in u back into our equation. So we get the integral from -2 to 2 of 1 over u du. Now, since you know your derivative identities, you know that 1 over u is just the derivative of ln of u. So we know that the integral of 1 over u is ln of u. So we have ln of u from -2 to 2, and now we can plug our u back into our equation. So we get ln of 1 plus x squared from -2 to 2. And now what we want to do is we want to take these bounds and we want to take the upper bound, we want to take the equation of this with the upper bound for x minus this equation with the lower bound for x. So when we do that, we get ln of 5 minus ln of 5. And obviously this is 0. And this is 0 because our original function, 2x over 1 plus x squared, looks like this. And I've showed you our bounds here. So these two areas are equal but opposite, as I've showed here. You can see I hope you can see the shading over here, making the area under the curve equal to 0. And that is how you solve this integral right here. Okay, so now we're going to move on to our next problem. Our next problem here is to find the integral from 0 to 1 over root 3 of 1 over 1 plus 4x squared dx. Now, to make this problem easier on us, we need to look for some identities. So we can take this 4x squared and just make it into parentheses 2x squared. So that'll help us with our u substitution. So for our u, we can take our u to be 2x, and our du is 2 dx. And since we want to make dx alone, we can say 1/2 of du is dx. And that'll make solving our integral even easier. So when we substitute u into the equation, we get 1/2 times the integral from 0 to 1 over the square root of 3 of 1 over 1 plus u squared du. Now, if you watch some of my other videos, you'll know that 1 over 1 plus u squared is just the derivative of the arctangent. So when we take this integral, we'll get 1/2 of arctangent of u from 0 to 1 over square root of 3. And now we can substitute our u into this equation, and we get 1/2 of arctangent of 2 of x from 0 to 1 over the square root of 3. And when we do this out, this goes away because that expression equals 0. And our final answer is 1/2 of arctangent of 2 over the square root of 3. And that was the integrals of a couple of questions using u substitution. That is all I have for you today. Have a good evening.